Amin is the digital unit head for the Kabbani Group. Experienced across design, development and construction, Amin is familiar with modern construction techniques, and he also develops onboarding programs for supply chain members to ensure sound coordination between Kabbani business groups. And his particular topic is the effects of BIM on rework and KSA projects. We all need that answer, so thank you.
We believe that the global market gap at the construction value chain in the past, over the past years was coming from the specialized contractors. We, as Kabbani Construction Group, specialized contractors, have worked very hard over the past 4 years to fill this gap in our projects. I'm going to share some case studies where BIM implementation processes have been implemented and reduced rework activities in our projects. According to a study of 47 KSA construction projects in 2022 and 12 MOH projects, the rework activities caused delays with almost 40% and money losses with 20%. The major impact of such delays is poor planning, coordination, scheduling, communication, contributed to projects delay with 75% of the original duration time. We are working in a very high fragmented industry, broken down into planning, design, construction, and operations. And so many project stakeholders are involved in the project with different business interests, which ends up creating a complicated series of transactions of information between all the parties during the project stages, to the point that the collective knowledge of the building information that is being produced is almost impossible to get because it is stored in different locations, stored in different companies, different countries, and sometimes in people's mind. This is why the ultimate goal of the BIM implementation processes is to describe one building by one database of information. The first case study is an office building for one of the ministries in Riyadh. It consists of 30 floors with total built-up area of 40,000 meters squared. The main scope for our company is to do the fit-out works. As a contractor, it's our responsibility to verify the as-built received from the client. Such verification, we used to do it with the traditional method, or the traditional way: visual inspection on site, take site measurements, update the drawings, checking specs, and move forward to the execution phase. However, such methodology puts the project at risk of rework and delays because of the human error and the information transactions. The other methodology that we followed is the 3D laser scanning, or the scanning to BIM methodology, in which we conducted 3D laser scanning for the entire building. We used the point cloud model, or we utilized the BIM, the 3D point cloud model and the panoramic images to create a 3D BIM model for the as-existing condition of the building for all disciplines: architecture, structure, mechanical, followed by a comparison between the as-built that we received from the client and the as-existing condition package that was extracted from the 3D laser scanning. We found too many discrepancies, and we were able to identify almost 345 design issues, architecture design issues, and 472 mechanical design issues. Such issues were communicated and coordinated with the client and designer early on through our common data environment, where we managed to connect all the project stakeholders in one single platform. Compare this methodology with the previous method, with the traditional methodology. We managed to decrease or reduce the rework activities with 26% of the original time. Coordination was enhanced, communication was enhanced, and all the issues were resolved early on. The second case study is a hospitality project where the scope of work was complete design and build project. During the tendering phase, the client requested us to do the project or to construct the project under the BIM process, which is the optimum scenario for us as a contractor, to have a single platform that connects all the project stakeholders together. When we connect all the project stakeholders together, we were able to carry on with the project phases and activities later on. In this project, we achieved different milestones. 3D coordination activity or milestone was conducted early on during the design phase. Design review and utilization of areas and spaces. construction drawings and schedules, BOQs, were extracted directly from the models. Models have, information is always available. And the most important milestone for us was the material submissions and long lead items. This was one of the major points this was one of the major points for us that caused delays and rework activities in our previous projects. We faced many challenges in this project. The major one is the supply chain that caused us a lot of rework activities. Unfortunately, the designer had lack of personnel qualification to meet the project requirements and to follow the project BIM standards and processes. Also, accordingly, the client had also many design changes at late stage of the project, which resulted in rework, stretched the project timeframe. The third case study is a private residential beach house project with built-up area of 15,000 meters squared. The client suffered almost 18 months of rework in design stage, because of the loss of information or the lack of coordination. BIM was introduced during the design. We implemented and solved almost 345 design issues for all disciplines. We managed to build a 3D BIM model with the required level of details needed to ensure that the model is matured enough to produce comprehensive, complete set of design package, fully coordinated. Last but not least, the fourth case study is a heritage project. This project was conducted during the pandemic and lockdown. The main objective is to coordinate between all project stakeholders, the reality capture team, structure and engineering team, structure assessment and an engineering team, geophysical consultant, archaeological consultant. We conducted the 3D laser scanning, and after we finished with the scanning, we published the panoramic 360 images on our server. And we gave access to our project stakeholders to easily access the project whenever they are and whenever they want, whether to move from a point to another, to measure a distance, angle, or to take a screenshot and communicate with each other. We completed the BIM model with high level of details. For example, the stones, we traced each and every stone and we modeled them one by one so that the archaeological consultant can later on carry on with the archaeological studies. Gained a huge benefit from our BIM model for the geophysical studies, where the geophysical consultant managed to integrate with his technology, with our model, to perform the subsurface geophysical analysis for the beneath the castle. We achieved a lot of milestones in this project. We reduced the overall project cost, minimized human errors to reduce the risk of rework. In fact, we eliminated completely the rework on site. We were able to complete the project 30% earlier from the project schedule. All the drawings and schedules were fully extracted from the model. The BIM model had become an asset to the client to be used in the redesign stage and as a record model for the historical phase. BIM is an intelligent model-based process for the construction industry that enables project stakeholders to exchange information in a better environment. It also has a significant impact in reducing rework arising from client changes, design changes, and design issues. Poor quality of information causes delays, and communication is a key in preventing rework. It's all about information. It's all about one single source of information. Nothing in the built environment is planned, designed, constructed, or operated without information. Thank you.